Okay, so today we're gonna go into biomass. So that's your chapter 12 in your textbook. Okay, biomass is nothing but just the materials like your wood, your crops, and waste. Okay, wastes come from crop, plant, mineral, okay, animal matter, all of that. We call them biomass. Okay, and we can turn it around and use it. It's kind of like a type of recycling. Okay, you can be able to process it into useful products. Yeah. So let's see how biomass works. So biomass is nothing but just waste, okay? Or you can call them just garbage. Like trees, lifeless trees, or dead trees. Okay, dead trees, branches, your yard clippings, your leftover crops that you can sell to the market, wood chips, okay, sawdust, bark, okay, from your lumber, yeah, mills, your used tires, and your livestock, alright, manure. And what we're gonna do is we're gonna burn, alright, these garbages, and you can get energy by the process of burning. Okay. Alright, so when we look at the data, we see, so we get about like 5%, okay, of energy used, of course, in the United States. So that's your 2015 data. So we got 43% from wood, and then wood derived biomass, and then we have 46% from biofuels, mainly ethanol, of course, and 11% from municipal waste. Okay, that's just all waste from your household, residence, also residential and commercial. 5% is, you might think like it's not much. Yeah, it is, but we are still learning the process of it. So once we get the process, we can increase the efficiency. Okay, as you increase the efficiency, the capacity, okay, of that biomass energy can go up. Yeah, so that's the way we master almost every processes. Yeah. Okay, so wood waste or wood garbage, so about 20%, yeah, total wood energy consumption. So that's again 2015 data from your book, come from your residential, yeah, sector. So for 2012 data, we use wood, okay, mainly for heat. So that's about like 2.5 million, right, households in the US. So 9 million households, they use wood as a secondary heating, okay, fuel. Okay, so if we take a look at the municipal, right, just waste, of course, solid waste. So we see, okay, Americans always throw away about like 4.4 pounds of trash every day. So 34% is recycled or compost. 13%, right, is burned and converted to energy. And then the remaining, okay, about 53% discarded. So that's pretty high. See? Only look at the 13% we burn and convert it back to energy. And we have about 85% household trash, alright, is gonna burn. About 61% of that is your biomass, okay? Meaning like biogenic, it means the material that is made from biomass, okay? So we can be able to utilize that, right, to do something good about it. If you want to watch, right, this video to the end, you can go to this to link right there. We don't have time to show the whole thing here. Okay, so in 2013, okay, we have like 80, okay, waste to energy plants. So that's a lot in the United States. So these plants, so these facilities, they burn like 30 million tons of municipal solid waste. Okay, so and then we generate about 14 billion kilowatt hours of electricity. So that's pretty good. So if you think about how how many households we can supply electricity, so that's about 1.3 million households, right? So many very large landfills like in Texas, they produce electricity and we recycle, of course. We use a methane, all right, gas. So this methane gas comes from biomass, right? Decomposes in these landfills. Okay, and biomass. So what do we have for biomass? We have agricultural crops like your corn, soybeans, wheat, okay? Because corn depends on the season. You can really mess up with the corn, right? Sometimes you got a great selling corn, and sometimes you got like a horrible, right, crops. So we can be able to recycle, use that biomass waste, right, for energy. Corn stover, we have switchgrass, right, bamboo, fescue, and miscanthus, right? These are all the energy crops, right? You may be like a little bit strange for these names, don't worry about it. These are just crops, right? That we can be able to use from agricultural sources. So if you know that, that would be okay. And I want you to get at least corn, okay? All right. Woody energy crop. So that's your hardwood trees and forestry residues. Okay, these are your stuff coming out, the forest dead, all right, trees remains coming out from your forest, all right, management system. So then we also have aquatic crops, your kelp, your seaweed, and your algae. Yeah, algae blooms are very bad sometimes. Yeah, industrial crops. So crops develop to produce specific chemicals, right, or feedstocks. And this we will get into this in detail later. All right, on Keynote plant. So animal waste, so waste from their farm, and then your processing operation, we can also use them as biomass. And municipal waste, your residential, commercial, and your industrial sectors. All right, garbage is coming out from there. Of course, we're gonna use all of that, right? Turn them into biomass energy. So waste, we're gonna use some particular processes right here, yeah, and then we're gonna generate energy, yeah. So this is a very good process. Okay, so Keynote is just a plant, alright? So they came from like from ancient Africa, and it's a very important, right, plant because of their growth rate is really fast for biomass. Yeah, we really use it in biomass because of that ability of that plant to grow fast. It's just a member, right? This plant is a member of hibiscus family. That's the plant species. It is related to cotton and okra, and most important thing is they can grow in many parts, right, of the United States. So when you take a look at the growth rate, you're gonna see like they can grow, all right, to 12 to 14 feet, all right, in 4 to 5 months. So that's pretty good growth rate. And this plant can yield like 6 to 10 tons, all right, of dry fibers per acre. So that's a really like 3 to 5 times greater than the southern pine trees growth rate, which can take, for southern pine tree, they can take about like 7 to 40 years to reach the harvestable size, all right? Of course, there are many different kinds of quinoa, right? Different species, different varieties. So some of them perform better, right, in certain locations, of course, and under certain conditions, they will grow better, right? They cannot run wild across the country like wheat, And that's a good thing because in all parts of the US, right, Keynote seeds cannot mature. So again, it depends on the location. Even if like generally they can grow, okay, in all parts of the United States, you still have to understand the soil, right, in that location. So it's a kind of a little bit tricky situation. Like this word, okay, it cannot grow wild, but you can grow with certain, okay, certain procedure, right? You have to watch and you have to nurture, okay? You can just like throw the seed onto the ground and wait for it to grow. It won't happen, right? So that's what it is showing. But you can do plantation for this plant systematically in all parts of the United States. Okay, so here we're gonna take a look at the biomass-based fuels and products. So the very first one is your ethanol, of course, yeah. So it's used to improve octane rating, right? Octane rating you can see in your car. So when you open your gas, right, to fill your gas to your car, you will see your octane rating. At the gas station, you can also see these ratings, yeah? And emission characteristics of your gasoline. Methanol, another one. So that's a natural gas and used as your feedstock. It burns, of course, cleaner, but has drawbacks, right? Some of them, especially uh, for the emission. And biodiesel and then vegetable oil, they come from your seeds, nuts, plants, recycled cooking oil, and animal fats. And pyrolysis liquids, so those are your thermal decomposition, coming from your organic compounds. Organic compounds when they don't have your oxygen. When we say organic, we're talking about these compounds carrying CH and then O. When you don't have oxygen, this one gone away. So that's what it's saying, absence of oxygen, You got your thermal decomposition. Biogas. Biogas is produced when bacteria, when they break down, okay, into complex organic compounds. And in common words, your swamp gas or landfill gas, right? So that actually comes from your bacteria working on the waste, yeah? Producer gas is another biomass-based fuel, so thermal gasification, okay, is your partial oxidation of your solid fuel. Oxidation is nothing but, okay, they are reacting with oxygen in the air. So at elevated temperature into a flammable gas, mixture. So that's just talking about all the products, and the fuels coming out from your biomass, your garbage, okay? So we get gas from the bacteria, gas from the thermal gasification. We got, alcohol, ethanol, and methanol. We got oil, biodiesel, and vegetable oil, and we got pyrolysis liquids, okay? Okay, so if we look at the 2015, okay, data, and we're gonna concentrate on electricity generation from your garbage biomass, right? So we see electricity generation, okay, across all sectors. We have like 11.3% of renewable electricity, okay, generation, and 1.6% total electricity generation in the United States, okay? So that's a pretty not so bad, yeah. And this is your 2015 data. So when you take a look at this chart, that's for your Midwest and West, Northeast and South, depends on the color, right? So make sure you match the color to be able to understand. So this one is for the South, and then this is your Northeast, and then West, okay, and then Midwest. So we can see the biomass electricity generation, comparison in the United States. So that's going like 2005, 10, and 15. So you can see the trend going up that way, yeah? Okay, so electricity generation from your biomass. So about half, of that electricity generated from biomass in 2015 data So you can see that was at industrial facility, right, outside of the electric power sector, meaning like we got it from the pulp and paper mills. Okay. So electricity generation from biomass, they use several types of fuel. So they are forest wastes and your sawmill residues, and then your urban landscape trimmings. Okay, you can just take in line the forest waste, dead trees, and the sawmills, all right, and the trimmings. Many of these power plants, all right, they use biomass as a substitute fuel, meaning like they're not using the biomass as a main fuel, okay, because they coal-fire the plant, okay. Okay, so we'll get into pros or advantages. So wood burning, right, is cheaper. That's why we use it for heating source. Yeah, wood. And biomass is normally grown domestically. Okay, and that's the reason why it helps, our local economies. And we use the right filters, right? We use the biomass stove. They can emit, right, less pollution. So that's the reason why we use a biomass stove instead of pure wood. And if you use coal or oil, right, heating, they also produce pollution. Okay, but if you use a biomass stove, they produce less pollution. And we also consider biomass, right, is like naturally occurring waste, like we got it from your useless dead trees, right? So you don't have to deal with producing that because we get them just free, from the environment. So it doesn't hurt the environment because they come from the environment, and also they come from our daily life, right? Your commercial and your residential and your industrial waste. So this definitely is a renewable energy source. Another thing, right, that is good about biomass is like it's definitely carbon neutral and it doesn't emit, same as here, more carbon, right, than initially stored. So that's a pretty good thing. So here's general, okay, pollution. Here we're concentrating on the carbon. And when we say carbon, we're talking about carbon monoxide. Okay, we don't want that. It's very poisonous in the atmosphere. Biomass, right? The next good thing is out there everywhere in the world. You can get it. Yeah, like I said before, they are from our daily life. Yeah, we produce waste every day. And if you think about the industrial biomass crops, right? You think like they might be created in remote areas, right? And that's a good thing, because it's not messing up with the cities. And on small scales for energy production. So the loss rate advantage is telling you that it doesn't really cost a lot, right, for you to be able to generate energy from the biomass, right, in industry, because you can do it in remote area. Also, you can set it up, right, in a very small scale for energy production. So the cons or disadvantages, you got to be very careful, right, about systematic filtration, because if you mess this up, you might get the greenhouse gases coming out, right, from burning your biomass. And it can scale back air quality. So make sure you come up with the right configuration and filtration. So to use a biomass, for heating or warmth supply, you need a large amount of energy, okay? And it also needs to be constantly applied, okay, into the system making the heat. And so that's a difficulty, and we're gonna call that as a disadvantage, okay? in the system design, but we can improve it, of course, gradually. So heating system, right, using biomass, right, they sometimes require electricity to work, okay? So even though you are generating heat, you can't just run directly without using electricity. So you still need the electricity investment in it, yeah? So that's a downside. In biomass, they require, a variety of storage area. Okay, so see, you can see the chips right there. Because of the quantity of power that you want to produce, meaning like you gotta burn a lot of biomass, right, chips, to be able to heat up, right, your house, right. So these are the things that are kind of downsides for using the biomass, right? Especially for heating the house. Okay, so other downsides are people are like, they're skeptical about biomass energy vegetation, okay, because they feel like, okay, they're losing the air, okay, quality in the environment. Another thing is like you've got to safely dispose your biomass after you use it. You can't just go and trash it out, okay? The ashes and the residue need to be taken care of carefully. Industrial capacity manufacturing, okay, of biomass is pretty low right now, and it's also not important technique, okay, especially for power production. So that's another downside. So your power crops, right, require a lot of area to store, right, biomass, and also you have to have very large area to store the residue after processing them. So storage, right, space is another downside. Meaning like you need a lot of quantities in order for you to be able to produce power. And after that, you have a lot of residues to clean it up, okay? So it's kind of very difficult, but then the only thing that's good is like you can turn the waste into something called product, but then you can't, the efficiency of using that product or biomass is still, we need to work on it, okay? So biomass has a limited power potential because of all these downsides, and you possibly can only cut, right? Not only cut a certain number of bushes, right? A certain amount of bushes in your forest. You can cut everything down anyway. So it's not a very good, potential. I mean, like you can't be able to depend on the forest dead trees and dead bushes, right, to produce biomass. And that's what we're talking about here. Alright, in these videos, okay, don't worry about it, and we'll be giving you some links at the end of the presentation, okay, at the end of the lecture, and you can visit these links. I'm going to show you in my next slide. Okay, so this is our last slide, and we post here, okay, some links, biomass videos, and you can go Google it. You can also watch the thousands of videos up there for you to learn on your own pace, right? But definitely I would recommend you to visit these 4 links, right? And spend some time, right, to study from it. I'm not going to run the whole thing right here for you. I'm just giving you a sample right there, yeah. And the instructors and also the professor, we chose them. And sometimes, the channel, they might take their video out of it. So make sure, but don't worry about it. You can just type, right, that in, and you will have several options, okay? Sometimes they move the video name or things like that happen. Okay, so that's it for biomass, and that's your chapter, I think, 12.